Today we'll start dynamic programming with this LeetCode easy problem, climbing stairs. So you're climbing a staircase. It takes n steps to reach the top. Each time you can climb either 1 or 2 steps. How many distinct ways can you climb to the top? So let's draw out the search tree for this using, for example, brute force. So basically, we can identify the recursive formula for solving this. For example, if we call the staircase as S of n, well, we can either take one step, so n minus 1, from the step before, so it would just be the n minus 1, or we can take 2 steps. So from the n minus 2. All right, so now that we've identified this recursive equation, let's draw out the search tree. So let's say we're solving 5. So 5, first of all, we have to solve 4 and 3. And to solve 4, we need 3 and 2. 3, we need 2 and 1. And depending on how we select our base cases, we can just choose 2 to be one of our base cases. Or, we can also go down to, for example, 0 here. And then this would be 1 and 0. This would also lead to 1 and 0. Okay. And then for this side of the tree, again, 2 and 1. And then this would be 2, 1, and 0. Of course, 0 would be where it starts. So if you were to take a look at this tree, first of all, you see that this is a pretty big subtree. And in fact, we actually do this calculation twice. One here and one's here. And you can even see within the subtree, we have another subtree, this 2, that we do the calculation for 3 times. And if you can imagine, the size of the search tree is humongous, and it takes way too long. And part of this calculation is that these subtrees that get repeated, we have to repeat these calculations. And so a classic way of doing dynamic programming problems is to just, once we finish doing the calculation, we use a technique called memoization, and basically note it down somewhere and save the result so we don't have to recalculate it when we encounter it later. In my case, you can do memoization either with the recursive way and just store the results as you go, or you can do it iteratively. I will do it iteratively here because doing it iteratively may save some time with the function calls, nested function calls, especially taking up time. Okay, so, well, first of all, let's define the array that we will use, like memoize, right? So let's initialize an array. And we'll make it of size n plus 1. And you'll see why I do n plus 1 later, because I want it to go from 0 to n. Okay, so let's consider our base cases. Our base cases, let's use 0 and 1. So to arrive at the 0th step, we only take one, like there's only one possible way to arrive at the 0th step, when you start out. And there's only one possible way to go to the first step, which is just taking one step from the 0th step. So actually, we can initialize these all to ones. And so from here, we can use a for loop. And since the 0 and 1 are base cases, we already know what values are. We'll start at 2. So 2 to n plus 1. And then we can calculate array I. Again, use our recursive formula we've defined here, n minus 1 plus n minus 2, and we'll do that. So in this case, it's I minus 1 plus array of I minus 2. So once this all calculates, we can just return the array, the last element of the array. Note that we are using an array and saving all the intermediate results in here, which takes O of n space. But really, if you take a look at what this is, we're only using the last 2 elements of the array. So we are wasting some space here. So we really only need to save the previous 2 elements. However, I'll just leave it like this, just to demonstrate the point. And if you take a further, upon further inspection, you can actually see that this climbing stairs problem is actually the exact same as the Fibonacci problem. So submit this. And there we go. That's it for this video. I'll see you in the next one.